if I'd tried. So let's take a look at this one that I got from Dylan. Hold on a minute. Let me put them side by side. They've changed this again. What the heck? Hold on a second. Sorry, I'm still trying to learn Windows 10. Yeah, this last one I got from Dylan has a lot of good stuff on it, so you might as well just use it. How come I can't blow this up? What? This must be, this is a JPG file. It should be.
It's not downloaded.
Oh, thank you. That's exactly what it is. If I download it, then I can blow it up. I always forget that. Yeah. Yeah, now I can edit it and expand it. This wasn't the best quality copy, but it'll have to do. That central angle is 148. What's the measurement of arc A?
148.
It's the measurement of arc B.
That'll be 148 divided by 2. Okay, the number's
74.
74.
Okay. Problem number 2. What's the general equation for measuring angle C? Oh, hold on a moment. Yeah, no, that's kind of what I want to ask. It's just they've drawn this a little funny. If I have two tangent lines, and they connect at A, theta equal to.
Theta is, second, I'm trying to move the controls so you can see better.
In terms of arcs, notice that all of these problems with circles, they're either talking about angles and degrees or they're talking about the measurement of segments. Well, this is clearly an angle and degree problem. So theta is what? The general equation?
110 minus d.
Almost. But in terms of my picture, it's arc, it's 1/2.
Oh.
The big arc
Minus the smaller arc.
minus this little arc. So in my picture, it's 1/2 of arc ABC minus arc AC. And you're almost always subtraction when your intersection point is outside the circle. It's only when it's inside the circle that you're adding. So what is C in our problem here? State it the way you said it.
So it would be C equals 1/2 times D minus 110.
Yeah. Now look at D and 110. What is D? How much?
250?
Yeah. In other words, you know that the sum of those is one full circle. So we know what D is. It has to be 250. All right.
Equals 125.
Yeah. Don't care so much about the answer as I do the general equation. Okay, here they're looking for this measurement right here. Let me go ahead. Yeah, let me go ahead and draw that.
You multiply the 78 by 2 and add it to the 115, subtract it from 360, and you have your answer.
Good, save me from drawing it. Number 4. Want to solve for angle F.
103 times 2,
Okay.
and then add 108,
Okay.
and then subtract that from 360.
And that gives you 46.
Divided by 2, and you have F.
You're good. That's a hard problem. Have you seen these problems before?
No, I haven't.
Okay. My number 5.
These ones I've always not been very good at.
What's that?
These ones I'm not really that good at.
Well, this is a tough problem here. I've been through these problems before, and I'm trying to remember how to do this. That's 98. Ah, now I remember. Excuse me. Think intersecting chords, angles. They fool you a little bit on this one. That angle's 78, right?
Mm-hmm.
But the two angles we need are that and that in order to solve.
Oh, if you subtract 78 from 180, you can get a supplementary angle.
Yeah, 102, 102. And now
So
what
then
do they say
has to be
102 is equal to?
98, or
No?
what?
No? It's a combination of that and that. It's the average between those two. So 102, if it's the average, it has to be what? 1/2 of 98 plus G. See what I'm talking about?
I think not really. But
Well, let's look at it again. I don't want you to give me a not really answer. Let's take away the 78. Okay? Because they gave that to us just to fool us. When I have two intersecting chords, regardless of where they intersect, as long as it's inside the circle, then this angle is equal to 1/2 of this angle or this measurement plus that measurement.
okay.
So I can say 102 equals 1/2 of 98 plus G, and then I can solve for G.
Okay.
G is 204 minus 98. So 106. But one way to help memorize this is to imagine that those two intersecting chords intersect at the center. Well, now this angle theta, if it's at the center, theta is going to be 1/2 of this arc plus that arc. Well, both of those are central angles, so they're both the same. So it's 1/2 of the same arc. So theta would equal to whatever that measurement was. I guess what I'm trying to say is that when you have a problem where you're not sure what the answer is, or the general formula, try to turn it into a problem where you know exactly what it is. In other words, if these two chords intersect at the center, you know that that's a central angle and it intercepts an arc that's exactly the same as theta. That's theta. And since that's also theta, that's also theta. So by using this model down here, you can verify that up here, 102 is equal to 1/2 of 98 plus g. In other words, if that's the correct general equation, then it has to apply even when they cross at the center. Six is a good problem, a really good problem. Hold on just a second. To look at it. What's the measurement from here to here?
180.
Okay, that gets us started. And they tell us the measurement from there to there is 26. So by definition, what's the measurement from there to there? Not by definition, but by whatever method.
154.
Now what is h? Because h is what intercepts that measure arc.
That would be 77.
Huh? Very, very typical of a geometry problem. You have to figure out this first, then you have to figure out this, then you have to figure out that. So 3 steps is very common. There's even a problem in here that has 4 steps to it. I don't know what number 7's doing in here. What's 7? What's the general equation for circumference?
Oh, it's 2 pi r.
So 2 pi times 23.
So 46 pi.
Yeah. This one is excellent. This is a 4-step problem. This is 7 pi centimeters, meaning it's an arc length, not a measurement of an arc. So, any idea on what our first step would be?
Finding the area of this, I have no clue.
This is a hard one. Yeah, to find the area, we're going to need the radius. To find the radius, we could use the circumference. I mean, if we had the circumference, we would find the radius. And to find the circumference, if we can figure out In other words, they're telling us the length of this arc xy. If we could figure out what percentage of the circle that was, we could backtrack and find the circumference, then we could find the radius, and then we could find the area.
To find the arc measurement of that segment, you could just multiply 63 by 2 and get 126.
Okay, cool. Now, let's start with the general formula, because that's the way to solve this problem. Arc length equals the circumference times what in this problem? (126) divided by what?
By 7 pi.
360.
Oh, yeah, okay.
In other words, if we take the percentage of the circumference, which is, we now know to be 126 over 360, it's about a third.
Mm-hmm.
If we take a third of the circumference, we get the length of this arc. And they've given us the length of that arc. So I can now plug in 7 pi for that. Okay? Now I can say 7 pi equals the circumference, which we know to be 2 pi r, times 126 over 360.
Cancel out the pi's.
Cancel out the pi's. There's only one variable in that. It's r. We're going to be able to solve for r.
So then you can multiply by 360.
Well, no. Once you solve for radius, now area is pi r squared.
Oh, yeah.
Okay? So it's all about being able to solve for a certain variable. And notice this was a four-step problem. In other words, the first step was to determine the measurement of the arc. That's one. Second step was to set up that equation, knowing the arc length is equal to the circumference times the measurement of the arc divided by 360. Third step was to solve for r. And fourth step was to solve for area based on r.
All right.
So this has become one of my favorite geometry problems. It appears to be a very simple problem. I mean, there's not a lot in that diagram, and that generally doesn't make for a hard geometry problem, but in that case it does. As opposed to 9, what equation can I write from 9?
Four x plus 7 equals 7x plus 8. 7x minus 8, sorry.
And how about 10?
X squared plus 63 squared equals 49 plus x squared.
So x squared plus 63 squared equals the quantity 49 plus x squared?
Mm-hmm.
Correct. And then when you solve for that, you'll even eliminate the quadratic nature of it, because when you square this, you get an x squared, which cancels out with that x squared, and you end up with an x and a bunch of numbers. And so you can solve for x. Now, I just want to point out one thing here.
Mm-hmm.
I have a tendency to confuse these two problems. If I told you this, what equation could you write? You have a tangent line and a secant line. Notice that in the problem we just did, that is not a secant line. It's close, but it's not a secant line. It doesn't go all the way through and touch the other side.
So
in my
49x equals 63 squared.
63 squared equals what?
49x.
No, here's what it is. It's 49, the part that's outside the circle, times the length of the entire secant line.
Oh, okay, yeah.
Okay? In other words, let's make these reasonable numbers so that we can talk about them. If that's 2 and that's 3, then what we have, and everybody has trouble with this, so it's 2 squared, the tangent line squared, equals the part that's outside the circle times the entire length of the secant line.
Okay.
Okay? Different than intersecting chords. When we have intersecting chords, it's always A times B equals C times D. In other words, it's one segment times another segment. Well, when you intersect outside of the circle, it's never that. It's always the segment outside the circle times the entire length of the segment. Notice that I could actually solve this problem had I drawn it like this, because now I know that diameter is 2x. So I could have said 63 squared equals 49 times 49 plus 2x. So I could have answered the problem without the Pythagorean theorem. But, I mean, it's silly to do that. The way you did it is the correct way to do it.
Yeah. Just
make sure that you get that 49 added to the x before you square it.
Yeah.
All right, Cole. This is going to be our last session for the year, I imagine, huh?
I think we'll probably want to keep going over the summer like we did last summer.
Okay, I'm going to offer a very similar deal. So, you want to begin next Monday, or you're going to be taking Algebra 2 next year, correct?
Yes.
Okay, well, I can certainly do the same thing we did last summer, which is kind of give you a head start and just review lots of Algebra 2 stuff. In terms of when you want to start, you might want to take a week vacation or a couple before we get started again. I don't know. You want me to?
I think we'll probably start right in.
Start right in? All right. Well, let me put you down for next 3:30 on Mondays.
Yep.
I'll put you down. Good. I'll have something to do next Monday.
Awesome.
Yeah. All right. I'll talk to you then, Cole.
Talk to you then.
Have a good one. Bye-bye.
You too.